Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy in Shamrock Banks Observatory. Today we're going to begin our discussion on learning the sky. And what better way to start learning the sky than to have a roadmap for the sky? So today we're going to talk about planetarium software. Now you can get apps for your phone that have planetariums on them so that you just hold up the phone and it'll show you what the stars are right in front of you. Or you can download something for your computer, which is what we're going to do. There's a lot of free planetarium software out there, and we're going to use one called Stellarium. So let's cue up the music and start learning about the sky. So let's dive right into it. The first thing that we're going to do is we're going to go to Google Chrome, which is what I use, and we're going to just simply type in Stellarium. The first hit is going to be Stellarium Astronomy Software, and that's what we want. So let's go ahead and click on that, and that'll take you to this page. Now up on top here, you'll see a variety of different types of the program that you can download. You can just use it on the web, which I wouldn't recommend. You can use it for Windows, or in my case, we're going to use the Mac version of it. Now we're just going to double click on that, and it's going to download a zip file to install Stellarium. When that's done, we're just going to extract it and install it using all of the default directories. And then what we're going to do is we're going to end up with the Stellarium program on our computer. We'll click the icon, and let's see what comes up. And this is going to be the default entry that we're going to get. Down here, you'll notice that there's a menu on the bottom, and then there's another one down here in the lower left. Let's go down and have a look at this one on the bottom. You see how it says Earth, Alma, 90 meters? This is a default location. Alma is a city here in Michigan, and 90 meters is its elevation. But we need to change that to our own location. So what we're going to do is we're going to open up this menu out on the side, and the top one that has a little compass on it is the location window. So let's go ahead and have a look at that. Now up here we have a search, and we're going to type in Marquette, Michigan. And that should be it right there. And then we can close it. Now what we have is the sky above Marquette, Michigan. I like to come around here and bring it to the north, just simply by dragging it a little bit. We can make it a little larger, or we can make it a little smaller. So let's make that just a little bit smaller. And right here is what's called the North Celestial Pole. Now you'll see that some constellations are listed here, and they're outlined as well. Down on the bottom, we can hit these icons down here, and we can turn the constellations off, and we can turn the grid off if we need to. So here's the sky above Marquette, Michigan. Notice that there's a little bit of haze down here just above the horizon. That has to do with the refraction of the lower atmosphere right by the horizon, so you don't really see very much down there. And up here will be where the stars are. Now, as you can see, we don't see too much, simply because there's some light pollution in Marquette, Michigan. Coming down here and going to this cloud icon, we can actually turn off the sky, so to say, and that'll take out all of the light pollution and show us exactly what we should see in the sky. Over here, as you can see, this is the Milky Way. These pink areas are nebula, and then we see a variety of stars. If you look right here, you'll see a familiar constellation to most of us. This is called the Big Dipper. It's what's called an asterism. It's part of a larger constellation, which is the constellation of Ursa Major. And if you'd like to see that, come down here to the menu, turn on the lines, and you can even turn on the name as well. So Ursa Major is the big bear. Here's the bear's nose. Here's his body. Here are the two forelegs, and here are the two hind legs. And then this is the bear's tail. The Big Dipper is just a portion of Ursa Major, which is why it's called an asterism. It's an easy to identify part of the constellation. If you look at these last two stars of the Big Dipper, and you form a line outward from that, and go out about 5 times the distance between those two stars, you're going to end up right out here. And just to the right of that line is Polaris, the North Star. And it's part of the constellation Ursa Minor, also known as the Little Dipper. Now, when you look at a map of the Earth, you'll see that there's a coordinate system on the ground of latitude, longitude, and elevation. Now, we have something similar to that in what's called the celestial sphere of the sky above us. And we need a way to locate objects in that sphere. So we use 2 different methods of doing that. The formal method is something called the right ascension and the declination. Let me show you what those are. Now, going back to Stellarium, we come down to the bottom menu right here. This first grid system you see is called the equatorial grid. So when we have this grid turned on, you see that the North Celestial Pole is located here, very near the North Star or Polaris. And this is 90 degrees north. And then as we move away from it towards the celestial equator, that declination goes down. The declination is the distance from the celestial pole. It goes down to the celestial equator, and then it starts increasing again towards the south celestial pole. Now, the other thing that you'll see is these radial lines, like spider webs. These are what are called right ascension lines. Now, this is an important difference between latitude and longitude and declination and right ascension. Declination is very similar to what we would call latitude on the Earth, and longitude is the same thing essentially as right ascension. There is, however, a difference, and that is that with longitude, you start at the prime meridian in Greenwich, England, and then you work your way east and west until you come around to the other side of the Earth at 180 degrees. In the celestial sphere, you start at that prime meridian, which is near Cassiopeia, and you work your way around west for 24 hours until you get back to your starting point. It doesn't split on the other side of the Earth. But when you're first learning the sky and trying to locate objects in the sky, there's another grid system that we can use, and that is called the altitude azimuth system. Let me show you what that looks like. Now, once again, this is what's called the polar system or the celestial grid. If we come down here and we turn that one off, and we go over to the next one, this is the altitude azimuth grid. This is your zenith directly over your head. Unlike right ascension, which is a little complex, these grids measure up from the horizon. And then as you go up, the number of degrees increases until you get to the zenith where it's 90 degrees. Now, the width of your fist when you hold it out fully is about 10 degrees. So if you start at the horizon and hold your fist out, that's 10 degrees, and then 20, and then 30, and 40, and so on. Now, these vertical lines that you see are actually compass bearings. These are true cardinal directions. So you have to correct for your magnetic variation, but this is what you get these right off of your compass. So if you want to look at, say, this nebula right here, it's going to be 15 degrees above the horizon and just north of northwest. That'll at least give you an area of the sky to look at. Now, this kind of gets you started in Stellarium. There's a lot of other features in Stellarium that we're going to learn about over the next few weeks, but this will get you just started. Now, something that you can do on a cloudy night like we have right now is you can learn a little bit about the clock in the sky using Stellarium. I've often said that you can tell the month by the position of the stars, you can tell the day of the month by the phase of the moon, and you can tell the hour of the day by the position of the sun. Let me show you exactly what I mean by that. Now, a couple of constellations that people are familiar with and can generally pick out are the Big Dipper, which is actually an asterism. It's part of a larger constellation, Ursa Major. And then you have the Little Dipper here in Ursa Minor. Now, one other thing that you can do is come over here to where this clock is, and you can set date and time and look at the sky on that particular date and time. So let's go ahead and change this a little bit. So let's go to December 1st, and let's go to midnight. So this is midnight on December 1st. Now, the next thing that I'm going to do is I'm going to make this a little bit smaller, and I'm going to change it over from the altitude azimuth grid back to the polar grid. Now, what I want you to do is look at the position of the Little Dipper, Ursa Minor. Notice how it's hanging straight down. What I want you to do is imagine a clock, just a standard clock face. And I want you to center that clock on the North Celestial Pole. And then I want you to reverse the 6 and the 12 and make the clock run backwards. So let me show you what I mean by that. If you were to imagine the clock centered on the North Celestial Pole right here, Ursa Minor on December 1st at midnight would be hanging straight down at 12 o'clock. So on January 1st at midnight, it will be at 1 o'clock, whereas on December 1st at midnight, it was at 12 o'clock. February, it'll be at 2. March, 3. April, 4. May, 5. June, 6, straight up. So for July, August, September. September's the 9th month, and it's out at 9 o'clock. October, November, and then back to December. So you see how it revolves around 1/12 of the distance every month? All of the polar constellations will move like that, and that's how you can tell what month it is simply by looking up in the sky. Now, again, with the moon phases, the moon goes through a cycle of about every 27, 28 days, and it goes through a series of phases. It starts with a new moon, which means you can't see the moon at all. A week later, you get a half moon. Then you get a full moon a week after that, 2 weeks in. Then it's back to a half moon, and then a new moon again at the end of the cycle, and the cycle starts over again. The sun, of course, moves through the sky during the day, and you can use a sundial to figure out what the hour and the minute are based on the position of the sun. You can also do the same thing to some extent with the position of the moon during the night, although that changes every single night. Now, there's 2 other programs that I want to mention briefly. Again, we're going to be going over these programs in much more detail later on in the series. However, this will at least get you started. 2 things that you really need to know when you want to go out and do observations at night is, well, what's the weather going to be? Are you going to be able to see the stars at all? The other thing is how much light pollution is in your area, because if you're out in the middle of Antarctica, you're going to have just a plethora of stars above your eyes. You'll be able to clearly see the Milky Way with your naked eye, and you may even see some nebulae and galaxies as well. However, if you're in downtown Chicago, there's so much light in the sky that you're going to see nothing but blackness. And the amount of light pollution in an area is graded on something called the Bortle scale. And it goes from 1, which is Antarctica, to 9, which is downtown Chicago. My skies here are Bortle 4 skies, bordering on Bortle 3. And they're not bad. But what are the skies in your area? Let's go find out. Now, here's the page that we downloaded Stellarium from. But what we're going to do is we're going to type in light pollution map. And just go to the first one. It's generally a pretty good one. So we'll click on that. Areas that are black, these are Bortle 1 areas. Now, as you get more and more light pollution, you start getting blues and then yellows and reds. So you see there's quite a bit of light pollution all through Europe, until you get out into Eastern Europe and then into Russia. Now, coming across the Atlantic, you see there's a lot of good skies up here in Canada. But if you look down here at the United States, there's a lot of light pollution in the United States. And you notice it's mostly east of the Mississippi River. And fortunately, my area is right about here. So I'm up in an area that's got a little less light pollution than we would have down in Detroit or over by Chicago. And then as you get out west, you get some really nice areas with low light pollution. That's why New Mexico and Nevada are good areas. Now, Baja California would be a great place to be an astronomer, but Atlanta, probably not so much. So what are your skies in your area going to be like, and what's your weather going to be like? Let's go to another website called Astronomy Tools. There's a lot of really good things on Astronomy Tools, But the one that we're interested on tonight is called the cloud forecast. So this is my cloud forecast, and as you can tell, this is all red. That means that it's going to be really lousy seeing and not a good night to take the telescope out. Why is that? Well, how much of the sky is obscured by clouds? It's 100% obscured. They break that down into low, medium, and high clouds, and as you see, I've got a lot of low altitude clouds here that are really thick. Sometimes you can get away with just a few high altitude clouds, but as long as these are here, you're going to have red on your observing condition. You can also see that we're having frost all day long. It's going to be snowing quite a bit tonight. Now, notice that the wind speed here is 17 miles per hour. The reason that the wind speed would be important is that will affect your telescope. Now, you may have a beautifully clear night. However, if you've got high winds, that'll determine your selection of telescope if you're going to be able to use anything at all. So, for example, on a high wind night, I don't want to bring the big beast out because that's got such surface area on it, it's going to vibrate in the wind. Maybe I'll bring one of the small refractors out, one that won't be affected by the wind quite as much. I'll go ahead and put the links for Stellarium and the 2 websites in the description of this video, and you can go ahead and just start playing around with that a little bit. See if you spot any constellations that you're familiar with. And then when we start going outside and actually looking up in the sky, at least you'll have some familiarity with them. So, until next time, this is Bob the Science Guy signing out from Northern Michigan. Our next episode is going to be an introduction to some of the constellations that we're all familiar with and maybe some that we're not. See you soon, take care, and stay well.